All right, let's kick off this deep dive. I gotta say, there are times when you stumble upon something that just makes you pause and think, wait a minute, is this straight out of sci-fi, or is this actually happening right now?
I know that feeling.
Yeah, and that's exactly what happened when I first came across Jay Poole's work, AI plus quantum results. Let me tell you, those results are definitely shocking.
Yeah, Poole's got a real knack for capturing the sheer speed at which this field is moving.
It's like we blinked, and boom, AI's suddenly being supercharged by, the whole mind-bending world of quantum computing.
It's a whole new frontier, that's for sure.
And for anyone who wants to explore further, definitely check out Poole's YouTube channel, Tech Frontiers. But for now, let's try to break down this whole concept of quantum machine learning. QML for short.
Sounds good.
What is it that really sets it apart from the AI that we're already kind of familiar with?
Well, it all comes down to the fundamental building blocks, right? Everyday computers use bits, those zeros and ones. But quantum computers, they use qubits. And these qubits can exist in multiple states simultaneously. It's really thanks to some pretty bizarre quantum phenomena, stuff like superposition and entanglement.
Okay, gotta be honest. I'm already feeling a bit lost.
What's complex stuff?
Is there maybe a real-world example you could give me, just to help wrap my head around all this?
Okay, picture this. You've got a coin. A normal coin, heads or tails. Simple.
Yeah.
Now imagine a qubit. A qubit is like a coin that can be heads, tails, or even a mix of both at the same time. It's as if it's spinning in the air and hasn't landed yet.
Ah, I see. So instead of just two possibilities, a qubit can hold a whole bunch of information at once.
Exactly. And that ability to exist in multiple states simultaneously gives these quantum computers a huge advantage when it comes to processing power.
I can imagine.
They can crunch through calculations that would take classical computers years, maybe even centuries in some cases, and they do it in just a fraction of the time.
Wow, that's wild.
It is.
So essentially, QML takes that quantum superpower and then applies it to machine learning algorithms.
Exactly.
What does that look like in practice?
Well, Poole highlights a few key QML algorithms that are already making some serious waves. One that I find particularly fascinating is quantum neural networks, or QNNs for short.
QNNs, okay. Those ring a bell. Aren't they sort of like the neural networks that we see powering things like image recognition and natural language processing these days?
That's right. They take inspiration from the structure of the human brain. But the difference is that QNNs, they leverage these principles of quantum mechanics to process information exponentially faster. And they can handle much more complex data sets.
So it's like taking the brain power of, like, 1,000 supercomputers and squeezing it all into a single algorithm.
That's a pretty good way to put it. And Poole points out how these QNNs are already being used to analyze incredibly complex patterns, like in fields like drug discovery and financial modeling.
Okay, now that's what I'm talking about. Let's dive into some of those real-world applications. I know Poole talks a lot about the impact of QML on healthcare, right?
Absolutely, he does.
Yeah.
He argues that QML has this incredible potential to totally revolutionize the way we diagnose, treat, and even prevent diseases.
Okay, you've definitely got my attention. Can you give me an example?
Sure. One of the most promising areas is drug discovery. The traditional methods of developing new drugs, they can take years and years and cost billions of dollars.
Yeah.
But with QML, we can actually simulate the interactions between molecules at the quantum level, so we can identify promising drug candidates much faster and way more efficiently.
Ah, so instead of all that trial and error in the lab, we can use QML to basically test millions of potential drug combinations virtually and pinpoint the ones that are most likely to work.
Exactly. Poole even highlights a specific case where researchers were able to use QML to identify a potential drug candidate for Alzheimer's disease in just a few weeks.
Wow.
A process that would normally have taken years using those traditional methods.
That's incredible. What about other areas of healthcare? How else is QML being used to, actually improve patient care?
Another key area Poole focuses on is personalized medicine. So imagine a world where treatments are tailored to your unique genetic makeup, to your lifestyle, to your environmental factors. That's the promise of personalized medicine, and QML is a big part of making that a reality.
So instead of a one-size-fits-all approach, we can use QML to develop those highly targeted treatments that are just much more effective and have fewer side effects, ideally.
Precisely. QML can analyze huge amounts of patient data, genetic information, medical records, even things like lifestyle choices, all to identify patterns and predict individual responses to different treatments. This gives doctors the ability to make much more informed decisions and provide patients with the best possible care.
This is amazing stuff. It sounds like QML really has the potential to completely transform the healthcare landscape as we know it.
It definitely does. And it's not just healthcare. Finance is also feeling the impact. Poole explores that quite a bit as well.
Finance, right? Always a hotbed for innovation.
Yeah.
What kind of shocking results are we seeing over there?
Well, one area where QML is making a big splash is fraud detection.
Okay.
Traditional fraud detection systems, they often rely on rules-based approaches, which, let's face it, can be pretty easily bypassed by sophisticated criminals.
Right.
QML. It can analyze massive amounts of financial data, and it does it in real time, identifying those subtle patterns and anomalies that often signal fraudulent activity.
So instead of reacting to fraud after it's already happened, we can use QML to proactively stop it before it even occurs.
You got it. And because QML can handle so much more complex data than those traditional systems, it can pick up on even the most subtle forms of fraud that might have slipped through the cracks before.
I can see how that would be a game changer for banks and financial institutions. Are there other applications in finance, though?
Oh, absolutely. Poole highlights how QML is also being used to completely revolutionize algorithmic trading. Imagine algorithms that can analyze market trends with incredible speed and accuracy, making those split-second trading decisions that can capitalize on even the smallest fluctuations in the market.
It's like giving Wall Street traders a quantum boost, allowing them to make decisions with almost superhuman speed and precision.
Exactly. And because QML can consider such a vast number of variables, analyze those complex patterns that humans might miss, it has the potential to generate some serious returns while minimizing risks.
Okay, I'm starting to see why Poole titled his work AI plus Quantum, Shocking Results. This is some seriously disruptive stuff.
Yeah, it really is. And we've only just scratched the surface of what's possible, believe it or not.
This is all so fascinating. But I do think it's time to take a step back for a minute and look at the bigger picture here before we get too carried away.
You're absolutely right. As amazing as these potential applications of QML are, we have to remember that this technology is still in its early stages of development. There are definitely challenges and considerations that need to be addressed as we move forward.
And on that note, we'll pause here for a quick break. When we come back, we'll dig into some of those challenges and explore what the future might hold for QML. Stay with us.
So, we've been talking about all this incredible potential of QML, and it's easy to get swept up in the excitement, right?
Yeah.
But as with any powerful technology, there are always, challenges that we've got to overcome.
That's true. And Poole doesn't shy away from addressing those challenges head on. One of the big ones that he points out is the sheer complexity and the cost of building these quantum computers in the first place.
Oh, absolutely. These machines are incredibly delicate. They need these super specialized environments to operate properly. We're talking super cooling them to temperatures that are colder than outer space.
Wow, that's insane. So it's not like we're all going to have quantum computers sitting on our desks anytime soon.
Not quite yet, but, Poole does make the argument that access to quantum computing is becoming more widespread. We're starting to see cloud-based platforms popping up.
Oh, that's interesting.
So this allows researchers and companies to kind of experiment with QML without having to build their own expensive hardware from scratch.
Right. It's like the barrier to entry is gradually being lowered, which could lead to even faster development of these QML applications.
That's what Poole seems to think. He even predicts that, within the next decade or so, we're going to see a huge surge in the number of companies and organizations that are using QML, using it to solve real-world problems.
Okay, that's pretty exciting.
Yeah.
But I'm guessing there are also some inherent limitations to what QML can actually achieve, even with all that incredible processing power.
Oh, for sure. One thing Poole emphasizes is that, QML algorithms, they're still very much reliant on the quality and the quantity of the data they're being trained on.
Right. Makes sense.
Just like with traditional AI, if you feed a QML algorithm data that's biased or incomplete, you're going to get results that are biased or inaccurate.
So it's not like a magic solution. We still need to be super careful about the data we use to train these algorithms, and we have to be aware of the potential for bias creeping in.
Absolutely. And Poole also points out that there are certain types of problems that even QML might have trouble with, things that involve a lot of creativity, intuition, human judgment. Those are still best left to us humans, at least for now.
Right. It's not about replacing human intelligence altogether. It's more about finding ways to enhance it and to use QML to tackle the problems that are best suited to its own unique capabilities.
Exactly. And that brings us to another important point that Poole raises, the need for collaboration between different fields.
What do you mean by that?
Well, he argues that we need to break down those silos between computer science, physics, mathematics, all those different disciplines. We have to do that if we truly want to unlock the full potential of QML.
So it's not just computer scientists working away on this in isolation.
Right.
It's about bringing together experts from different fields to share their knowledge and their perspectives.
Exactly. And Poole actually highlights several examples of really successful collaborations that have already led to some big breakthroughs in QML.
I like that. It's about bringing those best minds together to push the boundaries of what's possible.
Absolutely. And speaking of pushing boundaries, let's talk about the future of QML. Poole lays out some pretty mind-blowing possibilities in his book.
I'm all ears. What kind of future are we talking about?
Well, he believes that QML could completely revolutionize industries that we haven't even talked about yet. He mentions things like personalized education. Imagine QML algorithms that can tailor learning experiences to each student's individual needs and abilities.
Yeah, so instead of a one-size-fits-all curriculum, every student would have a personalized learning path that helps them reach their full potential.
Exactly. He also talks about QML being used to design completely new materials with properties that we can't even imagine today. Materials that are, stronger, lighter, more sustainable than anything we've ever seen.
That's like something straight out of a science fiction movie. Self-healing materials, super efficient solar panels, clothes that change color on demand. I mean, the possibilities seem endless.
Right. And those are just a few examples. Poole also gets into how QML could revolutionize things like transportation, agriculture, even space exploration.
Okay, you officially blew my mind. It sounds like QML is going to have a major impact on pretty much every aspect of our lives.
There's really no doubt about it. But as with any powerful technology, we have to approach it with, a sense of responsibility and foresight.
That's a good point. As we move into this exciting new era of quantum machine learning, it's really crucial for us to remember that we have a responsibility to use this power wisely and to make sure it benefits all of humanity.
Well said.
So we're back, and we've covered a lot of ground already. But I'm curious, this fusion of AI and quantum computing, what does the big picture look like? What kind of world could we be stepping into as QML continues to evolve?
Well, one of the things Poole argues is that QML has this incredible potential to tackle some of humanity's biggest, most pressing challenges. Like, he specifically points to climate change as an area where QML could make a real difference.
Oh, that's interesting. I can see how the raw computing power of QML could be incredibly valuable when it comes to analyzing all that complex climate data.
Yeah.
But how would that actually work in practice?
He talks about the work being done to develop these super sophisticated climate models, ones that can factor in this huge number of variables,
Yeah.
And these models, they're powered by QML, and the idea is they could help us predict extreme weather events with much better accuracy, give us more time to prepare, potentially save lives.
Right. So we're not just talking about understanding climate change better. It's about actually having the tools to, try to mitigate the effects. Adapt to a changing world.
Exactly. QML could also play a crucial role in making renewable energy sources more efficient, more cost-effective. Think about solar panels that can adapt to shifting weather conditions, in real time, or smart grids that can distribute energy intelligently based on demand and availability.
Yeah. It sounds like QML could be a key part of the solution when it comes to building a more sustainable future. Are there other global challenges that Poole addresses in his work?
Oh, absolutely. He also talks about the potential of QML to revolutionize agriculture. Imagine using QML to analyze soil conditions, weather patterns, crop yields, all to optimize farming practices and boost food production.
So instead of relying on those more traditional methods, farmers could have access to this real-time data, these insights that could allow them to make smarter decisions, leading to greater efficiency and sustainability.
Exactly. And Poole also sees a role for QML in tackling global health crises. Imagine developing personalized vaccines, vaccines that are tailored to specific populations or even individuals, or using QML to track and predict the spread of infectious diseases, but with incredible accuracy.
It's almost like having a global early warning system for potential pandemics, something that could help us stop outbreaks before they even really start.
That's the idea. I mean, the potential applications of QML are really quite mind-boggling, and it's clear that, we're just at the very beginning of exploring all the possibilities.
Yeah, but with all this talk about, technological advancement, it's important to remember that we as humans, we're still the ones calling the shots.
Right.
We have the power to shape how this technology gets developed and how it ultimately gets used.
That's a crucial point. Poole really emphasizes that As we move forward into this uncharted territory, this world of quantum machine learning, we have to do it thoughtfully or responsibly. We need to be having those open, honest conversations about the potential benefits and risks and make sure that this technology gets used for good, for the betterment of all of humanity.
Well said. As we wrap up our deep dive into the world of AI and quantum computing, I think it's safe to say that the future is both incredibly exciting and, a little bit uncertain. We have this amazing opportunity to use this power to solve some of the world's most pressing problems. But it really is up to us to make sure we do it in a way that's both wise and ethical.
Absolutely. The future of QML is truly in our hands. Let's work together to create a world where technology serves humanity, where it helps us build a brighter future for everyone.
And to our listeners, thank you so much for joining us on this journey. We hope this deep dive has given you a better understanding of the incredible power and potential of quantum machine learning. And we encourage you to keep exploring this fascinating field. Keep learning, because it's going to keep evolving.